All right, today's lesson is very, very different. Our objective is to draw, visualize, and define the centers and lines within triangles. So this is a very different objective than we've ever seen before. Very different verbs. You are absolutely going to need a ruler to help you get this done. So feel free to come grab one from me if need be. So if we look at the top left of your note sheet, there is a triangle, this one here. There's four of them throughout your note sheet, but this one is in the box with the perpendicular bisector and one other word, which we're going to learn in a second. So first off, we should define perpendicular bisector. And one thing we talked about today is making sure that, hey, we remember that perpendicular, that means 90 degrees. So if I draw a perpendicular bisector through all sides of our triangle, we should go about it going like this. First, we should use our ruler and find the midpoint of this line, this bottom line here. So I look and I use my ruler roughly. You can't see it because I'm on the computer, and I get my midpoint here. And then I want to make sure that whatever angle I rotate at becomes 90 degrees. So I'm going to use my ruler again, kind of rough it, and make sure that line's going straight up. We get a line of 90 degrees there. Your notes should look a lot cleaner than mine because I am drawing on a computer screen. You are drawing on some note paper with a ruler, so hopefully that gets a lot better. I look at my next side, I move to find the midpoint. It looks like that's a pretty good approximation of what the midpoint is. I'm going to then draw a perpendicular bisector here. So it's perpendicular, it's 90 degrees to that side. And then my last one, if I set up a midpoint about right here and then draw the perpendicular bisector from that, you're going to notice that all three of these points here, all three of these lines intersected on the same exact point. Okay, this point here is called our circumcenter. And what it's going to do is it's going to create a situation where we're equidistant from all the points of the triangle. Okay, so this point here, and this point here. And what can happen then is we can draw a circle that connects these 3 points. And I'm going to really rough it. It may not be perfect. It was rarely perfect in class today. And that circle that goes around all three of those points, that touches all three of our triangle points, the center of that is this circumcenter here. Notice how we're not really centered in the triangle, but we are centered in that outer circle, that circumcircle. So we're going to kind of rinse and repeat for 3 more triangles here, kind of starting off defining the lines that we're supposed to use for finding this center. And we're going to use an angle bisector. So with this one, we are going to divide each angle of our triangle into 2 congruent angles. So I'm going to show you what that looks like incorrectly first. If I were to take this top angle and draw a line that looks like this, notice how this left side of the angle is much smaller than this right side of the angle. Okay, that is very much not an angle bisector, so don't draw something like that. Instead, and this might take a couple tries, we are going to try to draw a line that cuts my angle in 2. Okay, so the left side of my angle should be approximately the same as the right side of my angle. I'm going to throw some congruency marks up here, just with some tick marks to highlight that that's what's happening. Same thing can happen with this bottom left angle. I'm going to take a stab at it first, inspect it, make sure that it's about a bisector there, cutting those in half. That looks pretty good, so I'm going to continue that line out. I'm going to make some congruency marks here. And this time, I'm throwing 2 tick marks, because those angles are equal to each other, but they're not equal to that top angle. And then lastly here, my final angle bisector here, throw on some congruency marks to show that, hey, these angles are equal to each other because I just split them in 2. So these points or these lines also create an intersection. They all 3 line up to the same spot. And this spot here is going to be what's known as the incenter. So this is equidistant from the sides of the triangle, and if the circumcenter created a circle outside the triangle, this point here is going to be the center of a circle that happens inside of our triangle. So if I draw a circle and it hits all three of my triangle sides, the center of that circle is this in-center point. So hopefully my sketch is saved if I jump back. If I jump back to our circumcenter, notice how we have a circle on the outside. If I jump to my in-center, we have that circle on the inside. And notice how both those points, the circumcenter and the in-center, those are in different spots within my circle. Okay, so they're not pointing to the same location. We found them in a different manner, and they're really kind of centers of circles, not necessarily a center of the triangle. So moving on, we got two more. This line in the bottom left that we're going to draw is called the median. This is drawn from a point, a triangle point, to the midpoint of the opposite side. So I'm going to kind of locate those midpoints like I did earlier in my problem. You guys can look at the top left triangle you had to make sure that you're finding those midpoints approximately the same. Looks like my first midpoint is about here. Use your ruler, use your previous sketch to help you. And what I'm going to do is I'm going to draw a line from this point up here all the way down to where I sketched that midpoint. A little bit off, so let me just try to redraw that real fast. Grab my eraser. And my midpoint located about here. I'll start trying to draw up from the midpoint and then drawing up to my triangle point. Boom. Again, you should have a much straighter, neater sketch than me because you guys are using rulers. On the left here, it looks like I have a midpoint approximately right here. I'm actually going to move that down just a tad to try to help with the accuracy of my sketch. And I'm going to draw from that midpoint down to the right triangle point. And lastly here, have a midpoint about here on my triangle on the right side. I'm going to sketch that to the left triangle point, and we notice that again all three of those lines intersect, and we get a nice instance of another point here. That what this one is called a centroid, and it is just an intersection point. It doesn't create a circle, it doesn't create anything, any other shape to do. There is some properties that are going to help you in your math 4 and pre-calc classes, but do kind of note that it is a little bit different than our in-center and our circumcenter. They end up in all three having different locations. I like the centroid the most if we're talking about a triangle center. This to me is what it should be, but again, it depends on kind of how you find it, how you approach it. All right, last one, dealing with altitude. So this is a perpendicular segment from a point on the triangle to the opposite side. So we have done a couple of these dealing with points. The median dealt with the point, the angle bisector dealt with the point, but then our perpendicular bisector was the only one so far that dealt with perpendicular. So we go back down to what we're working on here with our altitude, and we are going to start at this top point here. And instead of going splitting the angle like we did before or tracing to the midpoint like we did before, we're just going to draw that, in this case, straight down so that we get a nice perpendicular line connecting the opposite segment. So I have my point, I trace from that point, and I create a perpendicular line to the bottom. I'm going to mark 90 degrees there to show that's perpendicular. Now, we can do the same thing with the other ones. This one's going to be a little more difficult to draw. So that looks about right there. There's a nice perpendicular line connecting that point. And then finally, this one I might have screwed up a little bit. We're pretty close. Going point and creating a perpendicular line or a perpendicular segment for all three of those. That leads me to our last one, which is called our orthocenter. So that orthocenter there is just going to be the intersection point for all three of those altitudes. And again, if we look back all four of these point to different things within our triangle. The circumcenter, again, remember, is tied to that outside circle, that circumcircle that goes around, it circumvents the triangle. The incenter corresponds to that inner circle that touches all sides of our triangle. The centroid and orthocenter, differentiating between those two is a little more difficult. I typically think of that centroid as kind of the pure center of the triangles. If you look at, we're going from point to midpoint. So it makes sense that it kind of gets centered in our triangle the best. And then orthocenter doesn't have any connection to our circles, but does still give us an indication of a center point.